Okay, see Lindelof videos as promised, solving separable differential equations, and this is going to be our opportunity to apply what we just learned, just the simple algebraic part. So here we're asked to solve for y in the differential equation dy dx is equal to xy. This is what you have to be able to do. You have to be able to look at this and say, okay, I have a separable differential equation. And all I'm going to do is apply some algebra here. If you can look, I'm going to divide both sides by y, right? And I'm going to multiply both sides by dx. I'm going to end up with this. I'm going to end up with this separated differential equation that reads dy over y is equal to x dx. So hopefully you can see that all I did here was some algebra, just applied some algebra here. And actually it's just kind of intermediate or basic algebra. It's not even the most difficult algebra, but you have to think to do it. And then what I'm going to do here is to solve for y. What I'm going to do here is I'm going to take the derivative, I'm going to take the antiderivative of both sides. So all I'm going to do is apply this, take the antiderivative here, the antiderivative or integral there, and we end up with something that looks like this, don't we? And then I'm going to just start solving. Now, hopefully, what we have figured out is that we know that the derivative of a function over that function is an ln, isn't it? So when we take this integral here, dy over y is an ln, right? So we have ln of absolute y, right? Because we have to have non-zero values because of the ln, right? I'm sorry, non-negative values. I apologize. And then we get this here, right? And then to take the integral of this is just, right, this is to the first, so it's to the 2 over 2. So we have x squared over 2, like that, don't we? Remember, I got to be really careful about how I do this because part of this is technical and just technically has to be right. So I'm going to go back and clean this crap up a little bit. And I'm going to call this, it doesn't matter which one, you call this one C1 and this one C2. It doesn't matter one bit which is C1 or which is C2. I am going to, just to clean this crap up a little bit, we know these are constants because, right, this is the constant of integration. And that if it's any constant value, right, any constant value is C. So what I'm going to do here is this. I'm going to take ln of absolute y is equal to x squared over 2 plus C2 minus C1. And if you don't mind, can we just agree that C2 minus C1 is equal to C? Why? Because it's still a constant value. So all I did was just move the constant to one side. So I'm just going to call this C, if you don't mind, right? This is where it gets a little bit weird, and this goes to your skills in logarithmic functions and solving logarithmic functions. That to solve this, what I'm going to do is this. I'm going to raise both sides. I'm going to make these the exponential power of e. So I'm going to say e is equal to e. So this is what I'm applying here. And then I'm going to make this piece and this piece the exponential values, right? Because we have a log function here. So I'm going to try to solve that out. So I'm going to get ln of absolute y is equal to e to the power of x squared over 2 plus c. If you're asking why the hell would I do this, the answer is really simple. We know that ln is the same as log base e, right? So this is the same as log base e of absolute y. And I'm keeping that. And we know that, right, this is a rule that you just have to know. This is from the rules of logarithms. So I've done tons of videos on this, but this is from the rules of logarithms that any number raised to a log with a base that matches it is just this value. So e to the log base e of y of absolute y is just absolute y. And that was kind of one of the tricks. The other trick gets a little bit weird here, and I hope you'll buy this. I'm going to do this. I'm going to take e to the x squared divided by 2 times e to the c. And if you're sitting there going, Charlie, why the hell would you do that? Just, if you don't mind, I'm going to jump over here for a second and remind you of this rule because this is what I'm doing. Remember that x to the m, times x to the n is equal to x to the m plus n. And if that's true this way, then it has to be true this way too, reflexively. So when I'm looking at this e to the x squared over 2 plus c, this is m, this is n, and I'm going to put it back into this form. And you're going to see why in just a second. But I wanted to at least break out that intermediate algebra with you. So that's why I'm doing that. We're all actually almost done. To get rid of the absolute value signs, all I'm going to do is put plus or minus here. So I'm going to say y is equal to plus or minus, right? This is just another renaming stunt that's done in calculus a lot. This is a constant value. E is a number, isn't it? C is a constant value also. So e to the third power has a value, right? It's 2.71 to the third power approximately. And somebody's going to talk about the fact that's not exactly right, but it's more right than not. So all I'm going to do is say this as a little notation to myself. I'm going to say let e to the c power equal capital A. So I'm going to say equal capital A. Do I need to put that to the c power? I don't think I do. No, because I already qualified it here, didn't I? Good. Times e to the x squared over 2. And that's my final answer. Keeping in mind here, like, how the hell is that an answer? The answer is a family of curves. Family of curves. And you don't have to write that on the AP exam, but when you come up with this answer, you're like, what the hell? This is not a numeric answer. It can't be a numeric answer, right? Because we have these constants of integration that are bothering us. So hopefully you watched that last video, and we went through the basic steps of how do you separate separable differential equations. And I promised you, hey, given time, I'll show you what you would do with it. And this is what you're going to do, because there is no way, there is no chance that you're going to take the AP exam, the AB portion especially, and hell, not even the BC portion, and not see this. And I really want you to have this, because the national pass rate is really, really low for this exam. And by watching these videos I'm doing for you, I know that we're exponentially increasing your chances of passing this exam. So having said that, if you haven't already, wow, I can't even do it. If you haven't already subscribed, please subscribe. And if you have comments, if you know me, you know I get back to you, and I appreciate them, and I appreciate all the support. So ciao.